Hello, I am Bahram Haddadi. I and my colleagues welcome you to our virtual booth, LaserEye. As a short background for the motivation behind the LaserEye, I just want to start with a simple example. Looking at the cup of tea that we might drink daily, we want to know how much sugar did we add and how much should we stir it. So that means that we want to know about the process more, that we can control this process and optimize it. That's also true for industrial processes. Looking at them, we want to know more about them. So to gain more knowledge about these systems, we need to perform online measurements. So we need to measure properties such as velocity, chemical composition, and concentration. For measuring the velocity, we can rely on laser Doppler velocimetry, which is a non-mechanical interfering method and has very high sampling frequency. It provides us detailed information about velocity and turbulence in the system. For measuring the chemical composition and concentration, we can use, for example, Raman spectroscopy, which is also a non-interfering method. Using these methods individually won't provide us all of this information, and using them both together on a system won't provide us synchronized information at the same time at the same position from the same system. To overcome the synchronization problem, I and my team came up with a new technique. In this new technology, we tried to use the laser light from LDV not just for collecting velocity and turbulence information, but for collecting the extra scatter for further analysis, such as Raman spectrum. And doing such an analysis, we can measure not just velocity, but also the concentration and composition in the system. And we call this new technology LaserEye. LaserEye inherits parts of its features from its parent technologies, such as having no influence on the flow, being flexible in positioning, working in harsh environments, and being adaptive for different fluids. But of course, it has its own individual benefits, such as giving us synchronized information about the flow and concentration. And also by doing a proper design of the system, we can perform the measurement just using a single optical opening in the system. Based on the mentioned features, LaserEye can be applied to different industries, from food industries to chemical and petrochemical industries. But of course, it has its own usage in academia and also in research and development part of such industries. The proof of concept experiments have been performed and the first prototype has been designed, built and successfully tested. At the moment, we are working on construction of a low-cost probe for industrial application. Thanks for your time and attention. I would be interested to talk to you about your ideas to make use of this new measurement device and also about any questions you may have.